Hi everyone, thank you for joining. We'll starting the session shortly.
Hi, can you hear me?
Hi Tajinder.
Hi.
Yes, I can. We'll just wait for 5 more minutes, then we'll start the session. So we are waiting for everyone to join in.
Yes.
Hello everyone. So welcome to the another session of Data series. We will start the session in the next 5 minutes. Till then, let's get to know each other. We have put up a poll. Kindly answer those questions. Thanks everyone for joining us today. We'll start the session in 2-3 minutes. Let's wait for everyone to join and settle in.
Okay. Yeah, I'm just getting the voice two times. I'm not sure this is the issue at my end or and My voice is also getting repeated.
No. You are pretty good audible.
Okay. So my voice is also getting repeated.
Yeah, hi Tajinder. I just checked with my teammate. Could you restart from your end again because it's good from his side?
Okay, sure.
Is it good from your end?
Uh, yeah, it seems fine now. No, sorry. Again, the voice is repeated. I'm getting my voice back and yours also. Uh,
Hello and welcome everyone to the another session in Data series. We are thrilled to be here with you this evening for a session full of action-packed learning. Myself, Diksha, part of data science team at Analytics Vidya. For those who have joined us for the first time, a brief introduction of the Data session. The session is a series of webinars conducted by Analytics Vidya and led by the top industry expert. So it's a fun way of to understand the concept of data science, data engineering, and to way to understand the concept of data science and engineering, software engineering, and blockchain from the leading players of the leading players in the industry. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our speaker, which is uh, just a second, guys. Yeah. So now on to our session today, which is Advanced SQL, Analytics, and Window Function. SQL is an essential for carrying out data wrangling, preparation, featuring, engineering, and using analytical functions to perform complex EDA operation. In this data hour, the speaker will teach you how to use SQL for analysis and derive meaningful results. I hope you all are excited to attend this data hour with us. Before we kick things off and I hand it over to our speaker, a quick recap of the housekeeping items. We are recording the sessions and the recording will be available on our YouTube channel. The link you can find in the chat section. And yes, please use the question answer section for making any question you might have during the session. We will do our best to answer them as the data art process progresses towards the end. We will be bringing a feedback poll towards the end. You all are requested to kindly fill that up before leaving the session. We are just waiting for the speaker to join in, then we will start the session in 5 minutes. Now, on to our speaker. In this session of DataHour, we have Mr. Tajinder Singh with us. Tajinder is a full stack data scientist and in machine learning engineering with experience in predictive modeling, data processing, data mining, data engineering, and ML OOPS to solve challenging business problems. He specializes in interpreting and analyzing data to drive growth for organizations using data science. He's currently working as a senior data scientist and machine learning engineer at Spice Money. You can connect with him in LinkedIn. The link is present in the chat section. And we are also hosting this webinar live on YouTube to our official channel, and the channel link is present in the chat window. You can even follow up from there too. Over to you, Tajinder. The virtual stage is all yours.
Sure. First of all, thank you for the nice introduction. Hoping my voice is clear now.
Yeah, you are audible.
Okay, great. Thank you. Let me present my screen. So my screen is visible, right?
Yeah.
Both the presentation section and the query section also.
Yes.
Okay, great. Okay, sure. So good evening to all. My name is Tajinder. I'm working as a senior data scientist in the Spice Money. I have a total around 10 years of IT experience. I have, in my professional career, I have worked as a database developer, software engineer, worked on data scientist and ML applications. I'm also a certified TensorFlow developer. So let's start our session. Okay, so first of all, before this is the session this is the session regarding the SQL. So why the SQL is important in today's data world? Either it is a profile of business intelligence, data scientist, data engineering, or data analyst profile. In all of these, I think SQL plays a very important role. In my professional career as a data scientist, I use SQL almost all the days in my work. Okay. So this is a little advanced session where we will try to learn the SQL analytics functions, or also called as the Windows functions. So I am assuming that you have a basic knowledge of the SQL, like how to filter data, select the specific columns, or perform some aggregations on the columns. If you can just rate yourself out of 5 in the chat section so that I can see. I will try to explain the things according to that. It will be great. Okay, so let's continue. Fine. And I also want to remind that at least when learning a new thing, I always remind myself that learning is not a spectator sport. So I recommend you to practice all the things that we will learn, that we are going to learn in this session. And at the end of the session, we will also discuss some of the great practice resources for the SQL, where you can free practice the SQL queries. Okay, great. Okay, first, let me introduce what are the Windows functions. Okay, by the definition, a window function or an analytical function is a function which uses values from one or multiple rows to return a value for each row. Okay, when we apply any function on a column, so basically it applies on that particular row of that column. But when we try to use the analytical function, then we can also use some previous rows and current row and the following rows also to calculate the value for that specific row. I think when we will see some examples in the incoming slides, I think it will be explained better. Okay. Also, Windows functions are different from the aggregation functions. Let me check next slide. Okay. We can take an example. Suppose date-wise total count of transactions is given, and you need to get the total count of the transactions in a month. You will use the group by function or aggregation function. Okay, sum of the total transactions count, and you can get. But in that case, all the rows will be collapsed into a single output. Output will be according to the column that you are going to use in the group by clause. But analytical functions are different from that. In the analytical function, that sum will come as output for each of the row. Rows will not be collapsed. Number of rows as a output in the input and output will be the same. Okay, and also when we are using the aggregation function, either we will apply an aggregate function on the column, or we will mention that column into the group by clause. But in analytical function, there is not any such limitation. You can select as many columns in the select statement. Okay, this is a simple example, and this example with some of the little modification according to the requirement we will follow in our complete session. So we have a table, suppose, in which there is only a one column, serial. It represents a sequence. Values are sequence from 1 to the 10. Suppose we are applying an aggregation function, sum of serial column. So output will be 55. 1 plus 2 plus 3 up to the 10, it is 55. So this will be the single output here. And then when we apply the analytical function, the 55 output will be returned for the each row. We are not going to the syntax or how it is calculated. First, we are only just watching the difference between the aggregation function and the analytical function. Okay. Hoping it is clear. Okay. This is the syntax of an analytical function. There are total 3 parts. I try to differentiate these 3 parts according to the colors. First, when we define which function we want to use, function and the column name, and on which column that function will be applied. The next part is the partition by clause. If we want to mention some different partitions in our data. The third part is the defining a specific frame or window frame that will be considered to calculate the output. Okay, each of these part, that syntax part, we will try to understand that. Okay, first is the function and the column name. Here we will apply which function we want to use and on which column. Okay, some functions do not require a column name. It is not mandatory for all the functions, like row number, rank, and the dense rank functions, it is we do not pass the column name in these functions. When we will see what output these functions will generate, then you will also understand why it is not important to pass the column name in these functions. However, the functions like count, sum, lag, lead, first value, and the last value, we will pass the column name. And there are a lot of analytical functions. What we will try to understand here, the basic concept that how these analytical functions will be applied so that you can solve any problem that is related to that. Okay. The next part is the partition by clause. Okay. This is the same table in which two columns. First is the part and second is the serial. Okay. For part, in the first 5 rows, the value is P1, and the next 10 rows, the value is P2. And serial column then again consists of the values 1 from 10. Now, when we see this output, the same value will be generated for all the rows, 55. But suppose if we want to generate the total, but we need to define a partition in our data. So we can say that P1 is a one partition and P2 is the second partition. Okay. So then we will use the partition by clause. We will use sum of this column and then the partition by column part. So 15 will be the output for the first 5 rows and 40 will be the output for the next 5 rows, because wherever the part is equal to P1, so 1 plus 2, 3, 3 plus 3, 6 plus 4, 10, 10 plus 5, 15. Okay, then for the next part, partition P2, 7 plus 6, 13, and this sum will be up to the 40. Let me see an example. Okay, so this is the partition by example. You can ignore this part in our query. I can show you that I have a table named data with 3 columns. Oh, sorry, with 2 columns. If you want me to increase the font or the screen is not clearly visible, kindly tell me so that I can adjust according to that. Okay, so there are 2 columns in this. First is the part column and second is the serial column. Let me apply the analytical function here. So we are going to apply the sum analytical function here. So we read that there are 3 parts of the syntax. In this part, we are using only these 2. We are mentioning here the function which we need to apply, column name on which the function will be applied. Third, we are defining that partition by according to this part column. Okay. Now here we are seeing that 15 is the output for the partition P1 and 40 is the output for the partition P2. Okay, but let me remove this partition by clause. So we can see if I'm not defining any partition, then the complete set of rows will be considered as a single partition. We can say that the partition is a constant here. So the total will be the 55 for each row. Great. Next part of the syntax, this is also an optional part because in this query we didn't define any frame. So by default there is a frame. We will study about that. Third part is when we have to define a specific frame of rows from which the output will be calculated for a single row. Okay, so we can define either range or rows. Between start and end. Valid values for start and end can be unbounded preceding. Unbounded preceding means to consider all the preceding rows from the current row. Value preceding, here value is a variable basically. It can be 1, 2, 3 or any value where we are defining, suppose last 3 rows needs to be considered, or last 5 rows needs to be considered. A very simple example where we can use this. Suppose you have to calculate the moving average. I am taking the same example. Last 3 days data is given, and you need to calculate the moving average according to the last 3 days. Then you can define a frame for the last 3 rows here. Then current row, it defines the row on which for which the output is getting calculated. Value following, this is the following rows from the current rows with a specific value. Value is a variable here. Unbounded following means to consider all the following rows from the current row. Okay, let me see an example of this here. Now, this is an important slide. I want you to focus on this slide. So here, again, I'm defining two partitions, P1 and the P2. In our last example, the output was this gray color column, 15 and the 40 for each partition. But now here I have defined that we need to consider rows, one preceding and one following. Okay, so what will be the output for P1? This blue color. Okay, we know that we need to get the value for the first row, one preceding and one following. We are applying a sum function here. There is not any preceding row, only one, and the following row, one following row will be 2. So the output will be 1 plus 2 is equal to 3. Let's take another example. Suppose we need to get the output for this yellow row. The column value is, the row value is 4 here. One preceding value is 3, and the next following value is 5. So the output will be 4 plus 3, 7. 7 plus 5 is 12. Okay. Next, we see. Let me see the example of this green row. Now here, a new partition has been started. So calculation will be started from again. Here we can see that there is not any preceding row for this partition, and there is one the one following row will be considered. So 7 plus 6 is equal to 13. So output here is 13. Now let me check this pink row. Here there is not any following row. One preceding row will be considered. 10 plus 9, and the output is 19. Hoping it is clear. Okay, great. Okay. Let me also show an example here how we can define this. So we are using the same table, that is data. That we check the output of this column. Here I have applied the analytical function sum of serial over partition by again this part column. But what I have designed the rows between one preceding and one following. Okay, so we can see that we are able to generate this output 3, 6, 9, 12, 3, 6, 9, 12, then 9, 13. Okay, now when we are at this slide, we also used the partition by clause, and we also see that this order by, where this order by will be used and why it is important. So let me see where to use this order by. In our example table, we see that our serial column is already sorted. So the right side table, the green color. In this table, serial column is already sorted, and we get the sum by the for the partition P1 up to the 15, and for the partition P2, the sum is 40. Okay. Now let's check the left side column. here we see that the serial column is not sorted. So that's why at the end we got the same sum 15 and 40, but in between rows the sum is not correct because it is a cumulative sum, but due to with that our rows are not sorted, it is generating a correct value. We can see that let me see the third number row in both. Okay, the value is 3 here in both of these rows, but here the sum is 9 and in the right side table the sum is 6. And why is that? Okay, let me see first. If you I will share these queries on my GitHub in a GitHub repository, so you can download it from that. To generate the same output, because there is a little randomness by this, these rows are sorted. To generate the same output, you just need to run this query, set seed 0.5. So when we will set the seed to 0.5, we will be able to generate the same random values. Okay. Let me just see the only these two columns here. Let me set seed. Okay. This was. Yeah. Here we can see the values are not sorted for the partition P1 and the P2. So that's why the cumulative sum is not correct. But what if we will use here the order by clause, that we need to sort these values by the serial column. So we need to generate the same output. So we will use the order by here. The values are 2, 1, 4, 3. Let me set the seed to generate the same values. So now here we can see, because we have used the order by clause, the values are sorted 1, 2, 3, 4, 5, and we are getting the sum in the correct manner. So next is the difference between the rows and range. In this slide, we saw that either we can define rows to select a frame on which the calculation will happen, or we can also give a range. So what is the difference when we define rows and the range? Let me focus on this table here. In the second column, I have used the rows, and in the second column, I have used the range. And in this example, I have also added one more row here, which has the same value 10. So there are total 11 rows, 1 to 10. Then the 10 value is repeated here. When we will use the sum with the rows between unbounded preceding and unbounded following. Okay? Oh, sorry, rows between unbounded preceding and the current row. The value is like 1, 3, 6, 10. At the 10th row, the value is 55, and at the 11th row, 55 plus 10, the value is 65. But when we use the range, then we are kind of logically limiting the rows rather than the fixed, defining a fixed number of rows on which the operation will be performed. We are kind of logically limiting the rows. So it will consider the rows based on their value compared to the current row. So that's why value is same up to the row 9. But because the 10th and 11th row is same, and we have defined the unbounded preceding and the current row, and the current row value is 10, and the next row value is also same. So your frame will be extended up to the next row. So that's why in the last two rows, when we are using range to define the window frame, the value is 65 in the last two rows. Let me see an example, SQL example. I think this is as an example of rows and range. So one, in this, when calculating this rows example, I have used rows between unbounded preceding and the current row. And when I'm trying to in this the second column example, I have used rows between range between unbounded preceding and the current row. Let me run this query. Okay, here you can see the value is 65 for the 10th and 11th row. However, in this second column, the value is 55 and the 65 for 10th and 11th row. Just give me a second. Oh, hoping it is clear now. So let me move to the next slide. So what is the default frame in Windows function? Here I have written just one line. The default frame is range between unbounded preceding and the current row. But we will see this by example, that what is the default frame here. Here are some Windows functions that are available. The list is long, so I have defined I try to mention here some basic function, and we will also see some examples of these Windows functions. The first is the row number. Okay, as the name says, that row number will generate a unique value for each row starting from the 1. Okay, means it will be like 1, 2. For the third row, it will be 3. One thing I want to concentrate you here, that for the serial column, now the values are duplicated. So I have generated duplicate values intentionally, because some of the when we will learn some other functions, it will be more clear if there are duplicate values in the table. So that's why now there are total 10 rows, but the values are duplicate. There are 2 1s, 2 2, 2 3s, 2 4, and 2 5s. But the row number is generating a unique value for each row. So from 1, 2, 3, 4 up to the 10, unique value for each row. Second function, before coming to the rank, I want to explain the dense rank. These two are very important function. I have seen this question in many interviews, that what is the difference between the rank and the dense rank function. Okay, so dense rank will also generate a sequence for each row, but how it is different from row number, that it will generate the same sequence value for same column value. Okay, let me see. Row number is generating for first row 1, but for the second number the value is 2. But dense rank, because the value same, so it is also generating a sequence value same. So 1 and 1, and after that 2 and 2, and 3 3 up to the 5 5. So this is the dense rank function, similar to row number function, just it will generate the same value when the it will generate the same sequence value when the column value is same. Rank function is similar to the dense rank function, just with the difference, it generates the same sequence value when the column value is same, but it skip the sequence whenever there is a duplicate value. Okay, we can see this by example. So for the first value, when the serial column is 1, rank generated is 1. Now again the serial column is 1, and it will generate the same value 1. Now the serial value is 2, row number is generating 3, dense rank is generating 2, because 1, after that 2. But the rank function will generate the 3, because if there is not any if there was not any duplicate value, so the allowed sequence value here will be 3 now, but because there is a duplicate value, it generated the same value 1 and 1. So it will skip those values, and the number of values it will skip, it is equal to the number of duplicate rows. Okay, so let me see at the row 4, because the column value is 2, it is generating the value 3. After that, column value has changed, serial column, now it is 3, but again it faced a duplicate value above, so now it will skip the sequence value 4 and directly comes to the value 5. So this is the difference between the rank and the dense rank function. Rank function skips the value when they equal to the duplicate rows, but dense rank function do not skip the values. Sequence will be the same. Both of these functions will generate same sequence value for the same column value. Okay, let me see in a query rank, row number, rank, and dense rank. Row number, rank, and dense rank. Yeah, here is the example. Okay, row number is 1 to 10. Okay, rank is generating the same value, but it is skipping the sequence whenever there is a duplicate value, and dense rank is generating the numbers in the sequence and generating the same sequence value for a same column value. So this is row number, rank, and the dense rank. Okay. Next functions are lag, lead, first value, and the last value. I have colored the last values function specially in yellow because we will focus on that. First, let me understand the lag function. Lag function is a very easy function. Basically, it gives the value according in the last row. Whatever the value in the last row in the same column on which the function is applied. So suppose we are applying the lag function on this serial column in the last, when we are at the first row, there is not any preceding row because this is the first row. So for the first row, lag function will generate the null value because there is not any last row. Okay, when we come to the second row, so the last row value is the 1. So here it is 1. Next, when we are calculating the value for the third row, the column value is 2, but the last column value is 1. So here the value is 1. So this is the lag function. Next is the lead function. Lead function is similar to the lag function, but it just returns the value in the following row rather than the last row. So as the lag function generates the null value for the first row, lead function will return the null value for the last row because there is not any following row. So here we can explain these values. 1, then because here in the second row, the next column value is 2. So that's why lead is returning the value 2. First value, it will generate the first value in that partition. Okay, so whenever we apply the first value, we can see that the first value here is the 1. In the first row, the value is 1. So for all the rows in the when the first value function will be applied, for all the rows, 1 value will be returned. Now let me come to the last value. I think someone has raised the hand. Wait. Okay. Okay. I think there are some questions. Let me try to answer the questions first. Please mention the interface you are using. I'm using the DBEver for writing the SQL queries. Next, what is the use case application of sum over partition, one preceding and one following? Suppose you want to get the average of the previous day and the next day of the transactions, then you can use it sum over one preceding and one following. When we use the time series data now, do the feature engineering of the time series, it is a very common. Okay, sure. So okay, the hand raise was by mistake. So let me share my screens again. Okay. One more question here. 3, 4, how they come in the lead function. Yeah, that is I'm going to explain. Sorry, in the lead function, the next value will be considered. So basically, when we are suppose we are at the this 1, 2, 3, 4, fifth row. In the fifth. Okay, so when we are at this sixth row, so the next value is 4 now. So that's why how the 4 is come. But when we are at the fifth row, the next value is also 3. So the 3 will be returned. Okay. What is the time? It's 7:42. Let me come. So I think I have also explained this first value function here. Now let me come to the last value. According to the definition, we have learned the first value function. So the last value will also should be 5 now. 5 should be returned for each row, right? As the first value is returning 1 for the each row, last value should return the 5 for the each row, because in the row 10, which is the last row, the value is 5. So 5 should be returned for the each row. So let me see why 5 is not returned and this value will be returned. I mentioned here, default frame is range between unbounded preceding and the current row. When I was calculating these columns now, I used the default frame. So let me see the queries here. See the first one. Here we have lag, lead, first value, and the last value. So if we are calculating the last value, when we were calculating the first value, the frame was unbounded preceding. So all of the last value, all of the preceding values will be considered. But when we were calculating the last value, the default frame is unbounded preceding and current row. So to calculate the last value, we should have modified our frame up to the unbounded following. Otherwise, we will never reach to the last row until we are calculating the value for the last row. So that's why here, that's why the function is returning according to the value. Here the value is 1 and here the value is 2. And why the same value is returned here? Because the default frame uses range, not rows. That's why. So these values are same. That's why here the last value is also same. If we defined the range here, then it will return according to that. So I have modified the one more implementation of last value here. Okay, here I have defined the rows between the current row and the unbounded following, because when we are calculating the last value now, we should have access to all the following rows from the current row. So there is not any use of the preceding rows, because preceding rows will be used in the first value, and when calculating the last value, we have to use the extend our frame to the to use the following rows. So okay, now okay, we are at this example. Now we are getting last value rows is 5 for all the rows. Hoping this concept is clear. Can you paste in the chat window that this concept is clear? What is the default frame and why the last value is using? Okay, great answer from people. Okay, thank you, Lokesh. Thank you for confirming. Okay. Okay. Now, similarly, here we have calculated the sum. Again, I have mentioned this slide column values into the yellow because you can because you try to understand output according to the last what is the default frame. Because this is a common mistake I have seen while taking some interviews also. Because whenever there are duplicate rows, because by default the range is used, not the rows. So and it takes a lot of time. Then why it is showing the same value for same rows, and we are calculating the cumulative sum. So because by default the range is used as a Windows frame, not rows. Okay, so similarly, like we have defined here first value, last value, we have calculated the sum and the count according to the default frame, and the sum and count will be 1 minute. Okay. Now here the sum will be 2 because unbounded preceding, and the range because the value is same and default is range. So that's why both of these sum will be 2, and the next unbounded proceeding and not any following value. So here this is range 2, and the both of these values are 6. Hoping this concept is clear. Okay, now when I wrote this query now, I have used the same windows for all the for when calculating all the columns. So there is a very easy syntax for that. We can define a common window frame here, data window W as but W is a alias for that frame, and we can use the W in all our columns. Basically it will help you that your code is standardized and not replicated, so that if you have to change the frame and the query is very large, so you have to you do not have to change the frame everywhere. You can just change the value of this W, and this W will and the changes will be reflected everywhere. So it was simple. Now let me try to practice some questions. We will try to solve some live questions here. From the first question is from the lead code. I will also explain how I'm going to solve this question. Means what are kind of the steps that we are going to take. First, let me try to understand the question from the first question here is from the lead code. 1 minute. I'm not able to select here. Okay. So the question is, we have one table. The table 1 is employee, in which the columns are employee ID, name, salary, and the department ID is given. Second, we have a column, a department, in which department and the department name is given. So basically the second column is when we have to get the department name from the department ID. So we will use the second column. A simple join will give the value, the department name. Okay, so this is a question asked by Amazon Shopee, and it is a hard question mark on the lead code. Okay. So what is the output required? So we need a company's executives are interested in seeing who earns the most money in each of these company's department. Okay, a higher earner in a department is an employee who has a salary in the top 3 unique salaries of the department. Okay, fine, great. So we have to calculate the top 3 salaries according to the department. Let me see the slide here. Okay, here is the employee table. This is the department table. We need to get the top 3 employees according to the salary in each department. Like in the department 1, this 85,000, this 90,000. And one more thing, here I'm also seeing 85,000 value is duplicated here. So in the department 1, 85,000 salary is for the 2 employees. This will play an important role. First, see the always see what is the data given, so that you can kind of, if there is any assumptions you want to take here and ask from the interview, or according to the business requirement when you are doing some feature engineering or extracting some data for the analysis purpose, first try to see the data. Okay, here 85,000 is for the 2 employees. Okay, so when we were calculating the top 3 salaries, in the top 3, either one will be returned or both of these will be returned. Okay, let me check what is the output. Let me check the output table here. Okay, so output, oh, right. So we can see in the IT department, 4 rows are given. We need to extract it, the top 3 salary, but 4 rows are given because this Joe and Randy have the same values, same salary values. Okay, and this in the sales example is given, there are only 2 employees, so obviously that will be in the top 2 because there are only 2 employees mentioned. So that's why. So let me start first. If you know how to write the query, so you can paste in the chat window. I will see, it will be great. One minute. Let's go to the slide. Okay. First step, because in the output, we need to give 3 columns: department, employee, and the salary. And we have seen that we can find out the department using the join with the department ID. So we will join the department and the employees columns and we'll get the department name. Now, here is the I'm explaining the query. I'm not writing it syntax wise. Maybe we will write it syntax wise and submit the question. But first we will let me understand. So in IT, there are 5 columns. We need to get top 3 employees for each department. So partition by department, because top 3 in each department, then partition by department column. We have read the function row number, rank, and dense rank, by which we can generate a sequence for each partition. But what was the difference between the row number and the dense rank? When there are same values, row number generates the same value. So when we will take the top 3 here now, if we will use the row number function, then only these 3 values will be returned. So these 70,000 values will be missed. So to handle this duplicacy, we will use the dense rank function, because we have studied that dense rank function will generate the same values when there is a same column value. So let me write the query here. And I will try to write it fast due to the time constraint. So we need to first join the employee table. with the department table?
Please pardon me, Tajinder. I have
Hello?
an announcement to make. Yeah.
Please.
So, yeah. Hi, everyone. Before we proceed to answer your question, I would like everyone to the attendees to please fill in the poll about feedback, as it helps us to conduct more session. And we have 7 more minutes for the session. Yeah, Tajinder, you can continue. Sorry for the interruption.
Great. Okay, no problem. Thank you. So we have here v dot name, which is basically the department name, and salary, and the employee name, which is a dot name. Okay, let me run this query and try to see the output. Okay. I'm currently just checking the output. Okay, so my output is name, and salary. First is the department name, second is the employee name, and third is the salary name. So let me use our dense rank function here. Over. We will partition it by use the partition by the department name. So we know that v dot name is the department name, order by salary, order by a dot salary. Now we need to get the top 3 salaries. So it will be the descending order. I will name this column as D rank, dense rank. Okay. So here, writing it as a subquery. And one thing I think more mentioned in the column, return the result table in any order. Okay. So this is the department name. This is the E name. I'm writing it as E name, employee name, and D name and department name. So first let me check the output here, what the dense rank is generated. So here we have generated the dense rank. You can see for the 90,000 rank is 1, for 85,000 rank is 2, and next again 85,000 rank is 2, then 3, and after that 4, and for the sales department the rank is 1 and 2. So let me name as we will try to give the same name as required in the output, so that I'm not sure if the submission can fail according to that. Name is employee. Salary is salary. Okay, so we can say that where D rank will be lesser than equal to 3, giving it alias, where D rank. I think this should be submit. There is a runtime error. Not sure why it is that. Just give me a second. Why there is a runtime error? Let me try to use star here. Okay, star where D rank lesser than equal to 3. Right, we got the column. We just getting the D rank column extra. So D name as department. Just wanted to check if this is giving the error. Okay, then after that E name as employee. When we are mentioning E name as employee, it is giving the error. Are we using the same name? Let me do not give it alias. Okay, we are able to select the ename, then salary. Okay, just we need to give alias to maybe employee is already a table name. Oh, okay, fine. So this is accepted now. We have used it was just alias problem, I think. So department name, employee, and the salary. So we let me submit this solution to check all that. Okay, fine, great. So this was the question. That so I think whenever you have to question like to find top three or the least three, you will all row number, rank, or dense rank will be used. This will be next question. Due to the time constraint, I will try to explain here in the slide. That is also a very good question. I think it is important to explain here. So basically, this is the table. There is only one table. This is from the DataHour website. That is also a very good website to practice the SQL questions. Four columns are given: transaction ID, product ID, spend, and transaction rate. So we can say that transactions, we have given the product wise transactions. Okay. And what we need to calculate, we need to calculate the growth rate every year. The growth rate every year for each product. Okay, so first, what we will do, we will calculate, we will generate a column year because we need to extract the, we need to calculate the growth rate year by year. So we will extract the year from the date. Next, the product ID, current year spend. How we can get the last year spend value? We studied the lag function, which will give the value from the last row. So here we will calculate the previous year spend using the lag function. So here you can see the second row 1500.6 values there. For the first, we cannot calculate the value because this was the first row. So here we got the last year value, and then we will find the growth rate according to the formula that the current year so minus the previous year divided by the previous year. It will give us the percentage, multiply by 100. We will convert the percentage and handle the whatever the decimal places need to be handled according to the question. And this will, here is the year by year growth rate. So I hope you also understood this problem. Next section is some good resources to practice SQL questions. You can try lead code. On lead code, the database questions, you will get the previous questions that are asked by many FANG companies also, like Amazon, Apple, everywhere. And the DataHour, this is also a very good resource for practice SQL question. On DataHour, you will also get the statistics question, machine learning questions also, and then HackerRank SQL questions. Here the questions are organized according to the topic, like aggregate functions or easy, medium, hard. So on HackerRank, you will get the questions, SQL questions, organized according to the topic. So this is the session. And now the section is for question and answers. If you have any questions, you can ask. Okay, this is message from Lokesh. Thank you for the session. Majority of the concepts I learned tonight were new to me. Okay, great. If you have found something new, thank you for mentioning. Anyone, if there is any question, you can ask in the chat box. Okay, here are the questions. Okay. Any study material for the advanced SQL? I think there are a lot of tutorials on the internet. Usually, I try to read a topic, then try to solve the questions so that I can make sure that I got a good grasp for this on that topic. Thank you.
Thanks a lot, Tajinder. On behalf of Analytics Vidya, I would like to thank you for the time and for delivering such a wonderful session. I am sure our audience found it insightful, and hopefully we can conduct more sessions with you in the future.
Sure.
Yeah.
Okay. Thank you.
I hope you all guys have filled in the feedback form. And if not, I request you to fill in the form about the feedback, as it helps us to conduct more such sessions. And if you wish to conduct a webinar or are facing any difficulty in registering, contact us with the email mentioned in the chat section. And the recordings of the session will be available within 2 days on our YouTube channel. And the link for the same is also mentioned in the chat section. So we will be back with another session of DataHour on 14 Jan. The link is in the chat section for the same. Till then, we will have a good time and keep learning. And upcoming sessions are also mentioned in the chat section. Thank you so much. And if you have any question, you can also email to us. And yeah, Tajinder, you can continue answering the question if there are any questions pending. Thank you.
Let me see the chat box here. What are A and B while you were explaining employee and department? So I gave the A and B as an alias to the tables. So I can simply select the columns. To make the query simple, I try to use alias actually. Yeah, Vishnu has also answered the question asked by the Ritesh. Yeah, A and B are the alias for the table names. Any other question here? GitHub for getting these queries. I will upload these queries on the GitHub, and I think I will share the link with you. You can mention that in the video description. Okay, so that for the resources, I will. What an A and B alias. Yeah, currently it is not uploaded on the GitHub, Gulzar. I will share the link with the moderator. They can mention that in the video description. But where can we practice real data science projects? Any help on this? Kaggle is a good resource if you want to practice some real projects, but that is more related to the machine learning. But you will get a lot of data to the practice. Even if you want to practice feature engineering or EDA, then Kaggle is a good resource for the practice. For the upcoming webinar session, can we receive your invite in mail? I think moderator can answer this question. I didn't get it. Okay,
thank you, Tajinder. So
okay, fine.
I will end the session. Thank you so much for coming. It was
great.
Yeah, having a session with you. Hope to see you in the future again.
Sure. Oh, happy learning. Bye.
Thank you, and thank you everyone for attending the session. Hope it was helpful for everyone.
I'm disconnecting.
Yeah.
Okay, bye.